Good morning, Algebra 1 students. I'm going to talk to you this morning about zero and negative exponents as we start our new unit on exponents this morning. And I want to let you know, because I don't want there to be any confusion, that these notes follow exactly the class notes that I sent you. Runs about pages 1, 2, and 3. And it's going to help you do page 421 and 422 in your textbook. There are two rules that we're going to be working on today. The first one is zero as an exponent. And what I want you to understand, let's highlight this here, the rule, is that any number raised to the zero power is 1. So that's our first rule that we're going to work on today. And our second rule that we're going to work on today is negative exponents. And that is any number raised to a negative power is really the same as 1 over that number raised to the positive power. So let's write out those two rules for us today. Any number raised to the zero power actually equals 1, and any number raised to a negative power really equals 1 over that number raised to the positive power. Now with this second rule, you can actually do this also in reverse. So let's write that one down as well. If you have 1 over a to the negative n power, this really equals a to the positive n power. So you see that that negative exponent and positive exponent can be changed just by going above or below the fraction bar. Here are some simple examples we're going to do together. Now I rewrote the rules at the bottom of the screen for you, and notice that these examples explain exactly how to do page 421, numbers 9 through 20. So you might want to go ahead and do those right away as soon as we finish this part of the video. Just pause it, you can pick it up again later. So our first example, example A, is 9 to the negative 2 power. We want to switch this so it has a positive exponent. So we are going to use our negative exponent rule, and we are going to switch this to 1 over 9 squared, okay? Using our negative exponent rule, which 9 squared is 81. So this is 1 over 81. Now, example B may seem a little bit complicated because it is a decimal, but recall anything to the 0 power equals 1. So this, negative 3.6 to the 0 power equals 1. Okay, let's go to example C, and this is a negative exponent again, so we're going to move this below our fraction bar to get rid of the negative exponent and make it positive. So this will be 1 over 4 to the positive 3 power. 4 to the positive 3 power is 64. So this will be 1 over 64. Go to example D. Any number raised to the 0 power is 1. So again, this is 1. If we go to example E, we've got a negative exponent. Move it below the fraction bar. So this is 1 over 3 to the positive 2 power. 3 squared is 9, so this is 1 over 9. If we go to example F, I've got 6 to the negative 1 power. Negative 1 power always seems to freak people out a little bit. This is really 1 over 6 to the positive 1 power, and that's the exponent that is there when we don't see an exponent. So this is really just 1/6. And last, example G, I've got negative 4 in parentheses raised to the negative 2 power. This is going to be 1 over, keep it in parentheses, negative 4 raised to the positive 2 power, which is 16, so I have 1 over 16. This page of problems is going to help you do page 421, number 21 through 36. So when we complete this page, feel free to go ahead and do those problems. In pink at the bottom of the page, I wrote our rules down again so that we can reference them as we use them. And we're going to go ahead and simplify these expressions. Now keep in mind that when we say simplify, it means that we want to get all the exponents to be positive exponents. And what that's going to involve is using these two rules down here at the bottom of the page to make sure that all of our exponents are positive. So if you go to example A, you can see that we have b to the negative 2 power. We don't want negative exponents. However, if we use our rule, we can move b to the negative 2 down to the denominator and make it b to the positive 2. So only moving the things that have negative exponents, this becomes 5a to the third. That stays on top because it's already positively exponented. And we have b squared on the bottom. If we go to example B, we've got an x to the negative 5 on the bottom. In order to make that a positive 5 exponent, just move it up to the top. So what we're going to have is just x to the 5th. It moves up with the 1. Here we go. We've got in example C, x to the negative 9. Move it down below the fraction bar, 1 over x to the 9 power, all using this rule that we have outlined in pink here. If we go to example D, see we have a negative exponent there, move it up above the fraction bar. So this becomes n to the 3rd power. And keep in mind, its coefficient is 1. We don't have to write that. We can if we want, but we don't need to. Now example C is a little bit more difficult. Some things have a negative exponent like the C, and other things do not, like the 4 and the b. So the 4 and the b are going to stay on the top, and only the c will move to the bottom. So this becomes 4b, which stays on the top, and we have c to the positive 3rd power on the bottom. If we go to example F, don't move the 2. It doesn't have a negative exponent. Just move the a's. The a's are going to come up top, and we'll have 2a to the positive 3rd power. And the last example on this page, we have m squared on the bottom, but that's a positive exponent, so it's not going to move. But we have n to the negative 5th on top. We need to move that. Now, what happens if we move that is we don't have anything left on top. When that is the case, what you have on top is a 1. So 1 over m squared n to the 5th. This page of examples goes along with page 422, number 37 through 44. And again, I've written our rules on the bottom of the page. I think it's kind of handy for us to have those close by. And what we're going to be doing in these examples is we're going to be calculating some expression values when we're given values for the variable. So if we go to example A, I have what is the value of 3s squared t to the negative 2 power for s equals 2 and t equals negative 3. First thing you're going to want to do, get rid of that negative exponent. So we're going to move those t's down to the bottom of our expression. So our expression becomes 3s squared over t squared. And now what we're going to do is we're going to plug in 2 for s and negative 3 for t. So s is 2 and t is negative 3. And it is important, because t is being squared, that you put the negative in parentheses. So on the top, we do the exponents first. So I'm going to have 3 times 4, 2 squared is 4. On the bottom, I'm going to have negative 3 squared, which is 9. This gives me 12 over 9. Notice we can simplify this. We can take a 3 out of the top and the bottom. And this is going to give us a final answer of 4/3. All right, let's go to example B. And we've gotten an n and a w now that we're going to put values in for. But first thing we want to do, simplify our expression before we plug in our values. So w to the 0 power, remember, anything to the 0 power is 1. So that's going to become a 1. And we have n to the negative 4. So let's move those down to the bottom. So this becomes 1 over n to the 4th power, and n is negative 2. So 1 over negative 2 in parentheses to the 4th power, and this gives us an answer of 1 over 16. Let's go ahead and do our final example. Our w squared has a positive exponent, so w is not going to move, but the n will because it has a negative exponent. So we're going to write this as 1. Remember, it leaves a 1 up there, over n to the 1 power. We don't have to write it. W squared. When we plug in our n and our w, we're going to have 1 over. The n is negative 2, and the w is 5 squared. Remember, when you're simplifying, do those exponents first. So the 5 squared is 25. So 1 over, this will give us negative 2 times 25, which gives us negative 1 over 50. And it doesn't matter whether we put the negative on top, middle, or bottom.